So there are three main types of volcanism. One is called rifting, the other is called subduction, and the third, somewhat controversial type, is called hotspot volcano. All right, so those are the three main ones. The first two, rifting and subduction, occur because the Earth, as you probably remember from high school geography, is not one solid crust, right? It's composed of a number of different tectonic plates, about 8 or 9 large ones, depending on who you ask, and dozens, if not hundreds of little microplates. And these plates are not fixed on the surface of the Earth. They're actually kind of like rafts floating on an ocean. That means they're constantly moving, and in some parts they're moving apart from one another. And this is what we call a rift zone. And as plates move apart, it's literally pulling the Earth's crust apart. That allows for magma to be released from underneath as the pressure is released. And probably the most spectacular example of that is this little red line here that's called the Mid-Atlantic Ridge. It's the longest chain of mountains in the world. We just don't see them because they're underwater. They run from north of Alaska here all the way down past the Cape here in South Africa. It's just a massive undersea mountain chain. And you do see the occasional peaks that pop up here and there. Iceland is a pretty notable one. You might have seen some of the volcanic eruptions that occurred there not so long ago, disrupting air traffic throughout Europe. Also the Azores, which we'll visit, also on that rift zone. All right? So that accounts for the greatest amount of magma, basalt, that is released onto the Earth's surface every year. It just happens underwater for the most part. And then the second type of volcanism, and a much more spectacular type, and the one that is what caused most of the spectacular volcanism here in Northern California, is called subduction volcanism, right? And a great place to witness that is around the Pacific Basin here. This is called the Ring of Fire, the Pacific Ring of Fire. You've probably heard that at some point. It's the Pacific plate bouncing into the continental shelves all around it. And when one plate runs into another, one plate wins, and that's usually the continental plate, which causes the oceanic plate to dive under. It gets dragged under the continent. And as it sinks deeper into the Earth's crust, it melts, it turns into molten rock, magma, and then eventually the accumulation of this magma develops so much pressure that it has to force its way through onto the surface of the Earth. So all along the western edge of the Americas here, you have what's called arcs of volcanoes. Usually about 100 or so miles from the subduction zone is where this chain of volcanoes pops up. So all throughout the Andes Mountains, Chile is an amazingly volcanic country, all the way up through here into California, the Sierra Nevadas, if you go back 150 million years or so, was, for one, the edge of the continent. Everything that we're on now is accreted seafloor that has accumulated over several hundred million years, and then up into, say, the Cascades there where volcanism is still very active. All right, so that's the second main type. And then the third type is what they call hotspot volcanism. And this might be on a plate edge or it might be in the middle of a plate. It really has no discernible pattern. It just happens to be a supercharged upwelling of mantle magma, a really intense mantle plume, and Hawaii is a spectacular example of that. You can see it's right in the middle of the Pacific plate, so not on an edge, but nonetheless spectacularly volcanic. And apparently they do make wine in Hawaii. Has anyone ever tasted Hawaiian wine? Apparently they make it out of pineapples, which is maybe why it didn't make it into this edition of the book, but maybe for the second edition I'll consider... Sorry? They do have wine grapes. I don't mean to be mean to Hawaii, but we'll get there eventually. All right, so that's the basics of volcanism, and it kind of explains why and where. And this is a nice little Encyclopedia Britannica diagram showing just these phenomena. Here there's a rift zone with magma popping up there. When it gets split apart, you have this hot spot in the middle of the plate that just forces its way up. And here, as along the western coast of the Americas, is this plate getting sucked down. Magma then rises and creates these volcanoes. And of course, you also get the crumpling up of mountain ranges. And let's wrap it up in a little closer to home place here, Pacific Northwest in California. So I don't really need to explain this to you. You know you're in one of the most geologically active areas on the planet, right along that ring of fire here. And particularly that fault there gets a lot of press these days, the San Andreas. The reason why it's so active, it's because it's at the junction of 3 tectonic plates. So you've got the Pacific plate sliding upwards, you've got the Juan de Fuca plate sliding into the continent, and you've got the continent itself resisting all of this. And it's this triple junction that caused the massive eruptions, created the Sierra Nevadas, and created the volcanism that we are experiencing right here.